Hello everyone, and welcome to today's Energy Storage News webinar with Clean Horizon, where we'll be looking at grid connection limitations and their impact on battery energy storage system or BESS development. I'm Andy Colthorpe, editor of Energy Storage News and deputy editor-in-chief of publishing at Solar Media, part of the Informa Markets Group at Informa plc. Energy storage has been described over the years as various things: a silver bullet solution for renewable energy integration, the holy grail of the energy transition, and perhaps most famously, a Swiss Army knife in terms of its versatility. These metaphors are most commonly discussed in terms of how BESS is an important tool for transmission system operators to tackle the challenges of the 21st century grid. Of course, battery storage can help integrate rising shares of renewable energy, help manage peak demand, be an alternative to expensive transmission system upgrades by adding redundancy to networks, bring an inactive grid back to life through black starts, and much more. However, as you will hear today, the irony is that the BESS asset needs to access the grid to do all of those things in a grid-connected environment. Across Europe, some of the most congested pockets of the grid are the areas where energy storage is needed the most, but developers sometimes find these to be the most challenging places to win a grid connection agreement. In some places, the interconnection queue can bring nasty surprises as developers find their projects won't be able to connect for several years, jeopardizing their ability to build a business case. In others, the fees payable for using the grid can be prohibitive, with energy storage assets charged twice for drawing power from the network and again for injecting power back into it, which is another headache for anyone putting together their project's investment case. However, as we'll hear today, what happens once an energy storage system is connected to the grid can also be challenging for developers and their investment or business case. Clean Horizons experts will be sharing their insights on how various kinds of grid limitations can have an impact, and crucially, how to plan around and mitigate those impacts. Our speakers today are Samuel Porterbos, Partner and VP for Engineering at Clean Horizon, Rachel Loquet, Lead Consultant at Clean Horizon, and Clean Horizon Senior Analyst Amira Belazoglu. As always, we look forward to interacting with you, the audience. A Q&A session will follow the presentation, so please put your questions into the questions tab on the right-hand side of your screen. We can't promise to answer all of them, but we'll do our best to tackle a few, and Clean Horizon will be happy to contact you after the session to answer those we don't have time for today and to continue any conversations offline. Finally, today's session will be recorded and made available in the on-demand webinars section of Energy Storage News and on our YouTube channel in the coming days, and presentation slides will be sent to registrants. So with that, it's my great pleasure to hand over to our speakers, and our first speaker is Rachel Loquet. Over to you, Rachel.
Thank you, Andy. Hello, everyone. Thank you very much for joining today's webinar. We'll start with a few words about Clean Horizon. So Clean Horizon is a leading consulting firm specializing in energy storage. Since our founding in 2009, we have been providing stakeholders with expertise that is needed to navigate the very rapidly evolving energy storage landscape. We have two main types of services. The first one is market analysis and price forecast. So we track the global energy storage markets and regulatory developments. And we also provide price forecasts for electricity and ancillary services so that we can build reliable and bankable business models for energy storage across Europe. We are also technical experts, so we have a team that is dedicated to helping our clients through the entire battery development process. So that includes the grid connection, the permitting, the purchasing of equipment, up until the commissioning of the assets. So coming back to today's topic, as Andy mentioned, we will be discussing grid limitations. So as you probably know, one of the primary challenges for battery development in Europe is the access to the grid. We have a very rapidly evolving electricity mix in Europe. There is a lot of renewable energy project development, and so the grid capacity is reaching saturation across most European countries, and that makes securing a grid connection a critical step for the project development, and it can be even harder than finding a suitable land for the project. And therefore, in today's webinar, we will tackle a few questions. The first one being, what are the grid limitations and why are they needed by the TSO? We will then model the impact that these can have on the revenues that can be generated by energy storage. And finally, we will address which strategies can be adopted to limit the impact of those limitations on the project development. So starting with the first section, what are the grid limitations? So as grid connection requests increase, we have seen that in many European countries, there are a lot of grid connection requests for storage and other types of assets on the grid. The grid operators are offering flexible connection options, which means that they are allowed to temporarily limit a battery charging or discharging capacity. So this introduces, of course, operational constraints for the assets, but it also enables a larger number of batteries to connect to the grid, and that is therefore supporting the development of energy storage. The main reason behind these limitations is that the electrical infrastructure is being upgraded to accommodate increasing renewable energy generation, but since renewable have priority injection rights, the grid operator may need to curtail non-renewable assets, including storage systems, to maximize the renewable integration. So therefore, the grid limitations are mostly due to non-sufficient grid infrastructure compared to the development of new generating assets. And when the TSOs are including limitations, they can agree with a grid connection request without needing a large upgrade of the existing electrical infrastructure, which can be costly and cause delays. We can look at two examples to understand in which situations the grid limitations may occur. So for example, on the left, you have an example where the battery storage system could be constrained on the consumption of electricity. So in that case, the cable that links the production to the consumption is not sized enough so that it can transport the electricity for both the consumer and the battery when they are consuming at max power. So in that case, we are constrained by the cable, which doesn't have a large enough capacity, and it's the consumer that is competing with the battery for the grid connection. So in this example, we could have a constraint on the consumption of the battery when the consumer is consuming at max power, for example. So that is the first example. And on the right, you have an example where the battery may be constrained for the injection of electricity on the grid. So in that case, we have several power plants that are connected to the same substation as the battery. If the production plant, so here it's an example with PV, if it's a very sunny day and the PV is injecting at full power, then the substation is not sized enough that it can support both the full power injection of the PV plant and the battery, and therefore the TSO may ask the battery to stop injecting when there's peak PV production. That's the typical example that we see. There are some limitation profiles that are very linked to the PV production profile when the grid is not sized enough that it can support both the peak injection of PV and the battery. So these are two very simple examples of grid limitations, but it's important to understand that when you want to actually understand the limitations, you cannot just look at the cables right next to the assets and the infrastructure right next to the asset, but it's important to look at the region infrastructure to see where the constraints may lie, because they could be a bit further from the asset. So these are very simple examples just to understand the basic of when grid congestions may occur. So in which instances do TSO impose grid limitations? So there are two main types of grid limitations. The first one is when there's an early connection date. So they apply typically when grid reinforcements are being carried out, and therefore when while the grid reinforcement work are under progress, the asset may be limited on the grid while it is underway. And the other type of grid limitation is the permanent one, and this one has an impact on the project for its entire lifetime, so it will be constrained for the entire lifetime of the asset. And the impact of grid limitation on battery profitability also depends on when you're aware that you will be constrained with your assets. So again, there are two main types. There's the preventive grid limitations. So if the grid operator pre-plans the limitations, then the battery storage operator can adjust the strategies on the markets. So that is in the case where you know you're going to be constrained at least one day in advance, and therefore you can optimize your asset accordingly. The other type of constraint is a curative constraint. So in that case, the TSO hadn't planned in advance that there would be a constraint, or it thought the probability of having to curtail your asset was lower, and therefore it didn't plan in advance. And in the end, in real time, there's a problem and they need you to stop injecting or withdrawing. So in that case, you're not aware in advance, and therefore it can have a higher impact on your revenues, especially if you're doing ancillary services. And so Amira will detail more what can be the impact on both of those limitations on the revenues. But it's important to understand that there are two types and they have very different impacts on the revenues. So since the grid limitations are mostly driven by renewable energy growth, load increase, and also slower grid expansion, most of the European countries are facing similar challenges, and therefore the grid limitations are becoming the norm for energy storage projects. Indeed, most of the European countries have set very ambitious targets for renewable deployment, and the demand is also expected to the demand for electricity is also expected to increase in Europe. Therefore, the grid infrastructure is likely to be more and more saturated. And so TSO impose more and more limitations to be able to connect new assets without imposing very long delays or high costs for the grid connection. And it enables to connect new assets without those delays and costs, which can impact strongly the business case of a storage project. They can look a bit different depending on the country. So the grid connection agreements may have some differences. For example, in France, the TSO in the grid connection agreement will say what is the maximum number of hours where you can be limited and the maximum depth also of power of those limitations. And that gives you an idea of what's the maximum impact that you can have on your project. And in Belgium and Germany, for example, it can be a percentage of the time where the assets can be limited. So that is in your grid connection agreement. Of course, the TSO will be conservative on their estimate and base these numbers on the worst case scenarios. Therefore, when you want to build a business model for energy storage, it is important to understand what will be the actual number of limitations that your asset will be subject to. Because if you only look at the maximum, then you could overestimate the impact on the revenues of those limitations. So to build a realistic case of grid limitations, we can use the public data. So first, we can look at the current and the future status of the electrical infrastructure of the region around the asset to understand what's the cable capacity, substation capacity, and see where the constraints may be. We must also look at the current renewable installation and also the future ones. So there are plans for increasing renewable, as we said, on the grid, and this increase will have also an impact and constrain the grid in some areas. So we need to look at the future renewable expansion and also climatic scenarios, because depending on the year, for example, for wind, it's very important to have scenarios for weather patterns, because those can affect the production and therefore the constraints. And finally, the local consumption profile is very crucial. As we saw at the beginning, consumption also can impose constraints on the grid, and TSO objectives in terms of curtailment, how much power are they willing to curtail from renewables. And using those information, we can create several realistic scenarios of grid limitations for a given asset located in a certain area. And that gives you a better idea of the limitations, and therefore you can build a more realistic business case and understand the impact on the revenues. And that is exactly what Amira is going to introduce right now.
Thank you, Rachel. So, hello everyone. So far, we've seen that grid limitations have become a very common thing within most of Western European countries, mainly due to the share of renewables that keeps increasing. In this part, we will be discussing mostly how do we model and assess the impact of these grid limitations on the BESS revenues, and how by using our Cosmos optimization tool, we can define whether the secured grid connection for your project is a great deal or not. So first, as Rachel has explained, the grid limitations in the end are only hours of limitations where you will be prevented from having the access to the grid, either at full capacity or not being able to charge or discharge at all. And often those limitation hours are overestimated by the TSOs. So in order to have a more realistic, while assessing the project viability, it is crucial to run a more detailed analysis to have the real number of limitation hours by running a more detailed grid study, as we've seen just earlier, based on the location of the project and so on. And we will get a number of limitation profiles that we will be taking as an input in our optimization tool, Cosmos, in order to assess the revenue losses and the impact on the project profitability. For those who doesn't know about Cosmos, it's an optimization tool that will replicate how an aggregator would operate a BESS system in real life in order to generate revenues. So it will take as an input the technical parameters of the whole system, the size of the storage, whether it's hybrid or a standalone project, as well as the grid connection size. And in the other hand, it will also take price forecast of the different markets and the market rules for the participation. But most importantly, in our case, is the grid limitation profiles. So it is possible by using our tool Cosmos to implement the grid limitation profiles. So for example, if in your secured grid connection, you're prevented from having the access to the grid from January to March by 250 hours, it is possible to include that as a constraint before running the simulation. And of course, here we will be only tackling the preventive limitations, so those who have been already planned by the TSO in order to prevent grid failure, unlike the curative limitations which happen suddenly after a grid failure. So by using the multiple limitation profiles, we have seen that limitations do have an impact on the project profitability. So for instance, without any limitation, the project was able to reach 13.9% of IRR. And by subjecting it to the least constrained profile, we had a drop by 0.5%, 0.7% of the IRR of the project. And when subject to the most constrained profile, we had a drop of 2.5%, which is very significant. So in the end, limitations do have a huge impact on the project profitability. And when we have a choice, whether it's based on the location or multiple secured grid connection, is very important to run such sensitivity analysis before selecting the final location and grid connection for your project. So now we've seen the impact of the limitations on the project profitability. What about the differences between the charge from the discharge limitations? So in order to have an answer to that, we have run other simulations in order to answer to that question. And for that, we have taken multiple random limitation profiles from 500 hours to 2,000 hours of limitations, and we've applied them first only from the charge part and then from the discharge, and in the end we applied them both. So the final case was that the BESS project was limited from both charge and discharge. And the year that we've considered in this case was a year where the most dominant source of revenues was coming from ancillary services. So when the project was prevented from having the grid access, it was losing both capacity and energy activation revenues, which is quite conservative, because if we've considered a year where the project was going to do arbitrage and participate in wholesale markets, the revenue loss might be a little bit less than this case. So the findings of these simulations was that when we applied charge or discharge limitations, the revenue loss was quite similar. We went from a drop of 6 to 17% when subject to 500, from 500 to 2,000 hours of limitations. So both charge and discharge have the same impact on the revenue loss. And when we accumulated both limitations, the revenue loss did not double, but still it increased. And in this case, it ranged between 7 and 22%. So revenue limitations do have an impact on the project profitability. There's no major difference between the charge and the discharge limitations. Now, what about the penalties? So when your project is supposed to provide ancillary services, but at the same time it is subject to some grid limitations, how would that impact the revenues of your project, and will it face a risk of penalties? So to answer to that, it all depends and is related to the timing of the grid limitation and the notification from the TSO. Since most of capacity reservation markets, they close on the day-ahead basis, if the grid notification has been provided and sent prior to that, at least 2 days in advance, the project operator will be able to find alternative revenue sources. And if, for instance, the limitation was only for the charge part, we will be able to see what we can do on the discharge part, and so on. So if we receive the notification at least 2 days before it happens, there's no risk of penalties, since we will be able to take our precautions and not take engagements that we won't be able to fulfill. But in the case of receiving the grid limitation on the D-Day, or even worse, while providing the ancillary services, in this case, it might be very costly, because we have taken engagements to provide ancillary services, but in the end, we were not able to. So in this case, if we hadn't taken backup assets in order to provide what we've already what we've already taken engagements for, it will be very costly for the project, because we won't be losing only the revenues from the ancillary services we were supposed to provide, but also face huge amounts of penalties, which is why it is very important to have great partners to prevent these cases from happening and face less amounts of penalties, or not face them at all, which will be our next part for this webinar. And Samuel, the floor is yours.
Yeah, thank you, Amira. So of course, as you'll see, the topic of grid limitations is, I mean, it has two different sides. The first side is that it offers BESS projects the opportunity to access the grid which they would not have if the grid connections were to be granted without any limitation, because the grid is already saturated and the grid operator doesn't have enough capacity to make sure that every asset on the grid is able to operate as they wish in every situation. But at the same time, it creates a lot of issues on the development of the projects, because as Amira mentioned, it impacts the revenues in a uncertain way, because we don't know when the limitations are going to happen exactly, and in some cases they can lead to penalties on some of the services that were that's the project that planned to provide. So there are different ways those limitations can be addressed from a BESS operator perspective and from a BESS optimization perspective. The first possibility is to adjust the strategy of the asset in a way that is less prone to being impacted by those limitations. So as Amira mentioned, there is more risk when providing ancillary services on a project that is subject to limitations, because if the limitations happens at a moment where the system was already reserved to provide ancillary services and it cannot do that anymore, the optimizer needs to find another asset that is able to provide that same service. Otherwise, it would be subject to penalties. On other markets, there are other markets where the positions can be changed a little bit closer to real time. That can be the case with intraday and balancing, where if limitation notification occurs, there might be a possibility to change that position and adjust the program of the asset for the next for the next periods. That strategy has the advantage of being less risky and being less prone to giving way to penalties and to large deviations in the revenues. But at the same time, it tends to be also less lucrative, because it might not be the most optimal strategy to be employed to maximize the revenues of the asset. So there is definitely a trade-off here in terms of strategy, which is not an optimization strategy, which is not finding the optimal one from just a revenue perspective, but it's also finding the right balance between the risk of being subject to limitation at a certain moment and the marketing strategy that is being employed by the optimizer of the BESS. So that's definitely creates an additional variable in the optimization of a BESS, which is already a very, very complex world, and that means that finding the right partner, the right optimization, or having the right tools and the right strategies to optimize the project is key to ensure that the revenues of the battery are impacted. For instance, as Amira said, which is kind of a central scenario of how limitations can impact revenues, and not more than that by having a strategy that is a bit too risky compared to the probability of having limitations at a certain moment in time. So that's one first possibility: adapt the strategy, being less risky, having more flexibility into changing their positions closer to real time, in order to cope with this new variable that are limitations from the grid operator. Another thing which we're not really seeing for the moment, but we expect to see occurring in the next years, is having some kind of forecast or insights on the grid connection, on the grid conditions, and basically on the probability that the limitation will occur. There are cases in which this is relatively simple. For instance, in a solar region, you know that when the sun shines, and if you have limitations that are very linked to the presence of solar in the region, it is very likely that limitations are going to occur only during sunny hours. So the strategy may need to be shifted only during the solar hours, but for instance at night, since if there is no risk of limitation, a standard revenue maximizing strategy can be employed. Where it becomes a little bit more complicated is in wind, wind intensive regions, or in regions with a high level of consumption, or regions that for which the limitations are due to, for instance, flows between regions of between areas of the grid that limit the usage of a certain portion of the grid. This is definitely more complex to forecast and anticipate, and one of the key elements that will be required in the future to be able to optimize as much as possible and utilize the BESS as well as possible around those limitations will be the availability of information from the grid operators, which we know there are definitely different initiatives in that sense. In the UK, for instance, in France, on getting more information on the condition of the grid in a way that the strategy of the asset can be adapted in advance, and therefore that the impact of the limitations can be lowered. So we expect to see this as a trend in the next month and years, to have additional information being provided by grid operators and BESS optimizers taking advantage of these informations in order to optimize the BESS with a local variable that is the condition of the local grid. So this is what we are saying here, is that, and I think that should be a takeaway of the topic on grid limitations, is that knowledge of the market conditions will not be sufficient to optimize BESS. That will only be one variable to maximize the revenues of the BESS, but it will also be very important to know and understand the local grid conditions, and we expect tools and processes to be created around that idea that optimization on putting a BESS on the market will also require knowledge of the local grid conditions. Now, in what we're seeing in one impact, or one large impact that the limitations can have, is on the financing of the project, because limitations, by essence, are an additional uncertainty to the project. And obviously, what financiers and banks and investors hate in projects is uncertainty. Though it's either living with that uncertainty of grid limitations, or not developing the project at all, because as Rachel mentioned, finding a grid connection that is usable without any issue becomes more and more complex. Typically, what we observe is that for a project to get financed, it's not the only way, but it's one way that we've observed quite often, is to have part of the revenues being guaranteed by the route to market or by the optimizer, in a way that the banker or the investor has at least a portion of the revenues that is certain enough such that it can invest in that project. What we see is obviously that if you have limitations on the project, not only the expected level of revenues is going to be impacted, as Amira mentioned, but also the granted portion of the revenues is going to be impacted. And this definitely has an impact on the bankability and financeability of the project. We see basically two approaches. from route to market at the moment, even though that's a very nascent situation. But what we observe is that the position from aggregators is to consider that the floor or the guarantee level of revenues is reduced at the pro rata of the maximum reduction of revenues. So, for instance, as Amira mentioned, if the revenues are reduced by 6%, the floor is reduced by 6%. If it's only 6%, might be okay. If it's 15 or 17%, as Amira showed, that changes a lot the bankability of the project, especially if the revenue scenario is not entirely sufficient or is a bit or close to the bankability or viability threshold of the project. So, but also what we see, and that comes back to my earlier point on the strategy to employ, is that one way of guaranteeing revenues that can be employed is to consider that the guaranteed revenue portion is based on a, I would say, safe operating strategy that doesn't put too much impact or that doesn't create too much impact on the revenues when there are limitations. So, for instance, we can imagine that the guaranteed portion of the revenue of the project is based on only day ahead and intraday operation, which can be changed closer to real time on typically not subject to penalties if we do not unfold the position that we had programmed, or at least the penalties are not typically not as strong. So this means that the base floor revenues is not impacted as much as the central revenues. So that might be that is a way of still guaranteeing a sufficient amount of revenues on the project, while still being at risk of having a large impact on the overall revenues, because if we consider the revenue maximization strategy of the asset, this one might be a bit too impacted by the level of limitations. So there is definitely this kind of approaches that need to be applied by route to market suppliers in a way to ensure that the project with limitations remain sufficiently bankable. And of course, I mean, this is a very nascent topic. So we do expect that future offering and more route to market suppliers are going to prepare offerings and create knowledge and structure their offering around those issues. But just to give an example, also of the kind of structure that can be employed. The numbers are in these slides are illustrative only. They are not at all to be taken for granted as offers that we see. It's just an illustration of what can be provided. But the things that can be provided are, for instance, a level of floor guaranteed revenues that varies as a function of the number of limitations that are actually used by the grid operator. Because typically, grid operators, what they would do is, as Rachel said, take a quite conservative approach and say this is the maximum number of, or maximum percentage of the time, or maximum number of hours that can limit you over a certain period of time. But it's a maximum. It's not at all certain that the grid operator is going to employ all of that possibility. It depends a lot on the weather conditions, on the development of renewables in the area, on the actual consumption profile, on the and also on reinforcements on the grid that can happen in future years. So there is definitely an uncertainty on what actually will be the limitations. And the kind of offering that we see appearing on the market are guarantee levels of revenues that vary as a function of the number of limitation. That way, that ensures that if by any chance there are no limitations because the grid operator doesn't need to use that tool on that project, the guaranteed revenue is identical to a project without limitations. However, if there are actually some limitations, the guaranteed level of the revenues is going to go down. And as I mentioned earlier, what is very important in that case is the slope of that impact, and it's the role of the route to market, and actually one of the main things that will be looked at by banks and investors to make sure that even in the worst case of limitations, the guaranteed part of the revenues is high enough to ensure or to allow bankability of the project. Another possibility that we start seeing as well is having some kind of pooling agreements where several projects are put together in a way that if there is a limitation on a certain project that has taken a certain position, there might be another project somewhere else that can take that responsibility during that period. And we can completely imagine in the future that if you have several projects in different locations, they will not be subject to the same limitations at the same time. So one can take for the limitation of the other at a certain moment, while at a different moment, another project can take over for the project that taken over before for it. So there might be also this kind of aggregation and pooling strategies that might be interesting to consider in the future in order to mitigate the impact of these limitations and this additional uncertainty that is created by the fact that access to the grid is becoming more and more complex. And one thing that I didn't mention, but which I think is also important, is that what we discussed about limitations is actually very close to what would apply to hybrid projects that share connections with renewable power plants. It's just that in that case, the limitation is internal to the hybrid project and not external. But actually, the issue is very, very similar, and it's also something that we simulate, and we actually see very similar impacts of having, for instance, limitations that are due to being in the solar region or actually being hybridized with the solar project and sharing a connection with the solar project. So yeah, that was our presentation for today. I think we have a little bit of time for questions. So Andy, I give you back the floor.
Yep, we certainly do. Yeah, we have a few, almost 20 minutes for questions, which is fantastic. And yeah, thanks so much to the three of you for those presentations. I mean, it's really interesting to hear about the challenges of grid limitations that, I think a lot of people maybe know something about, but perhaps haven't looked in as much detail as you guys have. But it's also really interesting to hear from you, kind of the ways that you can mitigate those potential challenges. And also, I think in that very final couple of slides, the new sort of business models to get around that. So yeah, we've got lots of fantastic questions from the audience. As I said at the beginning, even with the extra time we have now, we're not going to be able to get through all of them by any means because there are many questions. But let's see how far we get, and yeah, let's have fun with this. So we did have a few questions from a couple of members of the audience pertaining, I think, to specific countries and grids around Europe. And I think, you guys do fantastic work, I know, at Clean Horizon, but I know you don't look at every single country in the world, obviously, at the moment, not yet anyway. So I think this is probably a fair way of approaching it. Tom asks, and thanks very much for your question, Tom. Tom says that grid codes, regulations, and limitations are strongly country dependent. So which countries is your simulation tool, Cosmos, currently active in? I'm not sure who wants to take that first, but yeah.
Yeah, perhaps I can take that. So on that specific topic of limitations, for now we've mainly worked on France, Belgium, and Germany, but we see that topic also rising in other countries, and our tool is flexible enough to accommodate the different regulations, because indeed there are differences from one country to another, and even one grid operator to another. So that's definitely a work that we do, and we see that this topic is very project specific or grid operator specific. So we design our tools in a way that is sufficiently flexible to be able to address every project specific questions.
Sure. Okay. And yeah, we promise that this isn't going to turn into just some sort of continuous discussion of the Cosmos tool, because we're here to educate, not just to publicize your great products. But David asks, and I think this is quite a pretty interesting question actually anyway, isn't it? So David asks if Cosmos can be used to negotiate with the transmission operator during impact studies. So I guess that's kind of during the modeling of the project business case, as opposed to once it's in operation, unless I'm much mistaken. And so David says, how can we work with grid operators to actually utilize these limitation results, which could be seasonal, daily, or customized dispatch, charge, and discharge limits in lieu of upgrades? So a bit of a long question there, but yeah, can Cosmos be used to negotiate with the transmission operator during the impact studies, and how so, if so?
So not definitely not directly talking about Cosmos, but I think yes, discussing with the grid operator is key to understanding the limitations. What is creating those limitations, in order to be able to have some kind of profile or view of how these limitations are going to unfold over time. So, for instance, is it more linked to solar? Is it more linked to a specific grid architecture? Is it more linked to wind? That allows to have a kind of profile, then can be used in a tool like Cosmos to simulate and check the impact that it has on the revenues and on the business model. I would tend to say that in the discussions with grid operators, usually they are just presenting facts from their impact studies and what they observe on their models. So the discussions are usually more about how can we narrow down these limitations? How can we have more precisions on what is going to happen over which years to what kind of conditions, etc., which I think is key in order to limit the impact on the revenues that these limitations have.
Okay, great. Anyone else want to add anything on that before we move on to the next question? No? Okay, so we did have a couple of a few questions about curative grid limitations, which is, I guess we can say, the unexpected side of grid limitations. And Harper asks, so thanks for your question, Harper. Which party actually performs the curative grid limitations? Is this the transmission system operator itself, or does the generator have to do that? Kind of, how does that sort of side of it, the actual implementation of those curative grid limitations work? If that's something we can go into, in brief detail, I guess.
I can answer this one. So for the limitations, the TSO, they may impose that you have an automatic device that enables the TSO to stop the asset in case it needs. So it's the TSO that decides when it needs the limitations, and you need to have a device on your asset, or make sure you can stop your asset yourself to ensure that you can respond properly to the limitations that you may have.
Okay, and I think this is a somewhat related question. Rainier asks, thanks for your question, Rainier. Is there any guarantee that the transmission system operator will only curtail when absolutely needed, or can they go to the maximum hours per year anyway? Now, obviously we don't, we can't really say anything about the motives of a transmission system operator. We have to assume the best in every case, I suppose. But yeah, I mean, I guess this really gets to the heart of how accurately can we forecast, maybe, Rainier, if you don't mind me rephrasing your question a bit, how accurately can we forecast, or how accurate can our expectations be on those curative limitations, I guess. And maybe that's one for you as well, Rachel.
Yeah, so in the grid connection agreements that we've seen, there's nothing stopping the TSO from reaching the maximum number of limitations that are in the grid connection agreement. So we can only expect that the TSO will not curtail the asset if it's not necessary. But then, for example, we talked about the preventive and the curative limitations. In the preventive limitations, the TSO plans ahead, and if it thinks there's a high probability of having an issue, then it will already say in advance to the asset that it cannot inject or withdraw. And in the curative one, it takes a risk for the next day, so it thinks there's a lower probability, but maybe in the next day there will be actually an issue. So even if the TSO tries to limit the number of limitations, if in real time there is an issue on the grid and it needs to be fixed, then it will still have to be used, and the impact on the revenues might be higher because it was not planned in advance. So in one way, it's better to have lower numbers of limitations, but in the other way, if you always limit the number of limitations, but then you have curative limitations which are even more impactful on the revenues, it's also a bad thing. So we expect that the TSO will not do limitations just to reach the max, but yeah, there's nothing saying that they can't reach the maximum.
Okay, sure. I guess it's about making sure that investors understand what those risks are, and that they're risks that they're comfortable with, and the operators as well. But obviously, ultimately, I think grid operators want to see storage on the grid because as we've said, it can be a useful asset. So yeah, hopefully kind of limiting the energy storage systems connection isn't going to be sort of one of their preferred options for managing their grid. So question here, I think this may be one for you, Mira, from Juan Manuel. So thanks for your question, Juan Manuel. And this may be a little bit complicated, actually. So I apologize if I've thrown you into something that is either perhaps a bit too detailed, or you don't want to give away your IP on how these sort of forecasting and tools are put together. But Juan Manuel asks how the grid limitation profile is generated, and if you can explain the rationality or the technology used for that forecast.
Yes, sure. So as explained, we did not take any technology specific while generating the limitations. We have considered a random profile, meaning that if we did not consider a BESS that would be close to a solar plant, for example, and in this case, we will be mostly limiting the project from the discharge from, for instance, 11 a.m. to 4 or 5 p.m., for example. In order for the study to be as most neutral as possible, we have considered to take only random profiles, and we studied to study the impact on the charge and discharge. And of course, if the power plant was close to a solar project, the storage plant that would have more limitations on the discharge will have less impact on the revenues than the storage plant that would have limitations on the charge, because they won't be able to benefit from lower prices during the day while the solar is producing at max. So yeah, it was mainly a random profile that has been used to stay as much neutral as possible. But in case we have more details on the location of the project, we are able to adapt that and adjust it according to the neighboring power plants in the tool.
Perhaps to complement what Amira is saying, this is what I mentioned, is that we We usually lack a lot of data in order to build this profile as of today. So building this profile is typically involves getting information from the grid operator, as well as checking available information on what will be the next grid reinforcements, what will be the future development of renewables in the area. It can also be a grid impact study that is being done on the local area to understand really what is the condition on the grid. And but there's definitely even though it's something that we do and we know other parties do in the industry, there is definitely a general lack of data available to be able to do that with a maximum level of precision that we could expect in order to reduce the uncertainty.
Excellent. I guess, yeah, the key to a lot of decision making is around not only volume of data, but quality of data, isn't it, I guess? And there's a question here around the impact on the case for ancillary services applications, I think. So this is from Frederick. Thank you very much for your question, Frederick. Do you take into account penalties from the grid in your losses if you don't deliver ancillary services? And also, I think, one interesting flip side to that coin, I guess, Amira, is that you were saying that the impact on revenues is perhaps less if you're performing arbitrage or energy trading. But yeah, why don't I let you talk a bit more about the impact on ancillary services to begin with, if that's a fair question to ask.
Yes, thank you, Andy. So basically, as explained, the revenue loss may greatly depend on what's the project is supposed to operate and in which market. So here we've considered ancillary services, but again, the limitations that we've taken into account are only preventive limitations. So the tool has already had as an input that the grid access was not available at certain hours. So the BESS was not engaged into providing ancillary services that it was not able to provide. So which is why in the calculations of revenue losses, we did not consider penalties, as we were not providing ancillary services while not having the grid access.
Okay, sure. And yeah, I'm just got one eye on the time here, so I think we've got time for a couple more questions, I think. And I think this is quite an interesting one from Adrian. So thanks very much, Adrian. How does a project protect its grid access capacity into the future to ensure that the TSO doesn't subsequently or retrospectively grant access to an alternative project? And if I can be a little bit selfish here and kind of add my own question onto this, I mean, reporting for Energy Storage News, we see a lot about rising electricity demand. And, a couple of years ago, that was often talked about in the context of adding electric vehicles to the grid. I think that's still the case to some extent. But it more commonly seems to be around, the data centers that are just potentially going to eat a lot of generation and, have consistently quite high demand. But yeah, why not start with Adrian's question, I think, because, he's the one that's registered to join the webinar, not me. So yeah, but how can people really plan? So we talked originally at the beginning here of this question and answer session, Samuel, about planning for the beginning of the life cycle of the project, and how can people think about what might happen 5, 7, 10 years down the line?
Yeah, very good question. I think overall the point is to secure the access to the grid, and securing the access to the grid means signing a contract with the grid operator. And I think accepting to sign a contract that has limitations is one way of securing the grid access. It's not ideal. We would all prefer to have a grid access that has no limitation. But if we want an access to the grid, we need to have those limitations. We need to accept those conditions that are given by the operator. because and you're entirely right. The usage of the grid is going to evolve. We're going to have more demand, more renewables, and the situation in the future might be worse than the one it is today. So it's probably better to accept an ideal, from a developer perspective, an ideal grid connections today, secure them, sign a contract, have a project built, rather than wait for the future, in which most likely access to the grid would be even more difficult than it is today.
Sure. I mean, obviously, predicting the future with 100% accuracy isn't, just not possible, is it? But I think there are probably, certain data and tools that you can potentially use to at least give yourself a good chance of having some accuracy there. And I mean, I think there's an interesting one from Marius here, actually. Marius, so thanks for your question. And I guess specifically asking about the UK and France, but we could broaden it out to a bit more general. Marius asks, are there any leading initiatives in the UK and France to actually gain more grid information from TSOs for forecasting? So, what I'm hearing is that there's lots of different levels of transparency in terms of TSO data that's available. So, are there any really common initiatives? I mean, I know that the UK, the UK regulator and government are kind of, they say, they are kind of quite committed to some grid reforms, and that is quite challenging work, but they do seem to be putting a lot of effort into it. Anything you can tell us about that?
Yeah, I mean, that's definitely an ongoing process in pretty much every geography and every country, with of course different timelines. But we usually already have some information available in several countries, in France, in the UK, of what congestions are actually present, what can be expected in terms of congestions. What we don't have usually is a profile. So what happens over time with the conditions to the grid. We know that in France, RTE said they would publish some profiles by the end of the year. There are similar initiatives in the UK, and other countries are also following. So yes, I mean, we will see more and more data available, more and more information being provided, and that will also probably change the approach of the whole industry on how to approach those limitations.
Excellent, thanks. And I think probably going to be our last question for today. So hopefully it's a good one. I think it's a pretty good one. And perhaps I'm a little bit biased in that because it does touch on a topic that we discussed actually before the broadcast began, and I kind of mentioned it in my introduction as well. But I think one of the key things that energy storage can potentially provide is relieving congestion on the grid. But at the same time, I think there's that discrepancy. I think you mentioned it previously in our discussion, Samuel. There's that discrepancy between actually battery storage projects not really being able to use the grid, or in fact being impacted by that congestion themselves. And so Telio asks, mentions that congestion relief is one of the battery storage applications, and which European TSOs or DSOs, that's distribution system operators, are utilizing battery storage for that. And if we can try and get 2 for 1, I think there's an interesting point from Nikolai. So thanks, Nikolai. Says, generally, wouldn't it often be the case that the battery would be incentivized to work in the opposite direction of the congestion, i.e. if there's a lot of solar, the battery would be incentivized to charge, not discharge, which obviously sounds very intuitive, but it's not always how things work in the real world. So I've kind of thrown 2 questions at you there at the same time. But yeah, I guess the first one around congestion relief, and then also, whether there can be a more proactive approach, I guess, from TSOs and other stakeholders to kind of to mitigate that congestion through battery storage systems.
Yes, definitely. That's a very good point, because it's entirely counterintuitive. We're saying the BESS revenues are being reduced by congestions, when actually grid congestions management is an often cited service that can be provided by battery storage. The reason for this, I think, is that at the moment we still don't have any large-scale, very remunerative initiatives to pay for the congestion relief services. There are some initiatives. There are some initiatives in the UK, in Germany, in France, and in other countries, but they are usually still more at a pilot or project level, and there's no like organized market service for this kind of service. But it's definitely something that we could see in the future. The initiatives are taken today by grid operators definitely go into that in that direction. And what is today an issue or a problem in the BESS development, which is having limitations to access the grid and not being able to provide all the services all the time as we would want to. Maybe in the next 3, 5, 7 years, an opportunity for that same project at the same location, because actually there will be a service in place that will remunerate the fact that the battery is going in opposition to what the local condition of the grid is. But to this, there needs to be new services and new markets to be developed, which is an ongoing process, but it's still, I would say, at its inception in most cases, in most countries.
Excellent. Well, thanks very much, Samuel. And of course, yeah, thanks to Samuel and to Amira and to Rachel, our 3 excellent expert speakers today. It's been a great presentation. Now, in preparing this webinar with you guys, I've learned a lot, and yeah, I think it's been really illuminating for me, and hopefully even more so for our readers and the audience that have attended today. So yeah, most of all, I want to thank actually the audience for their attendance. Been really well attended webinar today, and as I said, I promised at the beginning that we would try and answer as many questions as we could. I feel like we did a pretty good job, but there's still dozens more questions on that list there. So I think Clean Horizons team will have a busy old time and a fun time answering those, and yeah, perhaps getting into some conversations with the people that asked them. So yeah, so with all of that, just one final thank you to everyone involved today, and from my personal point of view, thanks to everyone who's involved in this fantastic industry. It's just been so exciting to see it moving forward always, and I think what today's session really shows is that where there are challenges, there are also lots of smart people working on the solutions to those challenges as well. So with that, I'll conclude today's webinar, and thanks again for joining us. Bye for now.